All right. Good evening, everyone. Um, Here we are uh, in our academy gatherings every Monday, 7 o'clock. Today, Gaurav Rizal will be giving a presentation on spectroscopy of T-Tauri stars, and you have the floor.
Okay, so spectroscopy of T-Tauri stars. A quick overview of T-Tauri stars. Classical T-Tauri stars are the adolescence of stellar evolution, and the star is near the end of its growth will almost fully formed with a luminescent disk and ongoing accretion. And the accretion disk typically lasts like 2 to 5 million years, and though some stars take as long as 10 million years before losing their disk and completely emerging toward maturity, strong magnetic activity leads to Ripley's path on the stellar surface. Some T-Tauri stars are still hidden inside the disks and they're not ready to emerge just yet. Um, so, what exactly is spectroscopy? So, spectroscopy is a branch of science concerned with the investigation and measurement of spectra produced when matter interacts with or emits electromagnetic radiation. And these kind of studies apply to start mostly since spectroscopy deals with large scale measurements, and stars are actually quite big. And it has been harder to do this for Detroit stars because of the accretion disk that comes in the way. And we need to use IR to get around physical disturbance of the accretion disk for younger Detroit stars. So Detroit stars, their spectroscopic observations. So up to this point, these stars have been classified as irregular variables. Hundreds of T-Tauri stars are now known and have mainly been found through spectroscopic searches. T-Tauri stars can be further divided into two types and are based on spectroscopic characteristics that arise from the disk properties: the classic T-Tauri star and the weak T-Tauri star. So the classic one possesses extensive disks and results in strong emission lines in their spectra, and the weaker ones are surrounded by a disk that is very weak and no longer in existence. And the weak T-Tauri stars are of particular interest since they provide astronomers with a look into the early stages of stellar evolution unencumbered by nebulous material. But where has this material gone? Perhaps into planetesimals which collide together to form planets. And that's like down there is like a spectroscopy chart. And yeah, so the photometric variability, which is the second part of my presentation. And here I found this study, use Kepler data to study the precision differential photometric variability of solar type and cooler stars at different time scales, ranging from half an hour to 3 months. And they determined the diagnostic that characterizes the mean differential intensity change between data bins of given time scale. And we apply the same diagnostics to SOHO data that has been rendered comparable to Kepler. And these are basically like the different points that they saw, and this is the S index and the R per. And this is basically the same chart, but basically like it's on the largest like time scale because there's way more points. And you see like there's a pattern going up like this, like kind of like a sine curve. But then when you zoom in here, there's like it's kind of hard to see a pattern, but they're kind of like in this oval right here.
Gaurav, Pranat has a question for you.
Oh, okay.
Yeah, the type of variability of few months to even time scale of several years. Well, why so different?
Oh, I found these
Like
pictures
hours and months. Yeah.
of some studies done, and they wanted to basically like see what the pattern was when they took different time intervals. So this one is basically like a really long time. So you get to see a pattern that emerges over time, like over a long couple of years of getting data, and see the leads to are like the ones that you actually see a sign for pattern. So yeah, does that answer the question?
I mean, just to adding up, this photometric variability can have different causes. You could have, for instance, the star and that's what you guys are working on. If the star has any sort of a spotting systems or dark spots or bright spots, as the spots come in and out of view, you're going to detect some variability, some photometric variability. That's one possibility. Second possibility, if you are talking about classical T-Tauri stars with accretion disks, then material from the disk, as it falls on the star, can also produce photometric variability.
Okay.
As the star rotates, you might be able to visualize that. Another possibility is the star might undergo some pulsation. So in the case of Kepler, since they are able to observe photometrically, which means to measure uh, light changes with very good precision, they can detect pulsations or different modes of pulsation that is intrinsic to the star. I mean, all the stars undergo pulsation. The sun does pulsate, and so any other stars. So depending on the type of precision you have on your instruments that involve, the telescope you have, involve the detection system you have, then you might increase your range of precision, and then you might be able to infer more diagnostics and more properties than you could otherwise.
Okay, I see. So I'll go to the next one. So what photometric variability means in T-Tauri stars is that photometric variability is expected to be the greatest in ultraviolet with smaller but significant variable variations produced in the near infrared. But then we mostly gain the data from the ultraviolet spectrum, and we suggest that variable stellar magnetic fields, specific fields, may contribute to long-time scale photometric variability of T-Tauri stars. The long-term variability of T-Tauri stars may therefore provide a clue to the nature of magnetic dynamo scales in these stars, and you can use photometric variability stars like stuff like find death stars and stuff. So I'll go to the next one now, and these are my sources, and yeah, thanks for listening.
Thank you. Very good.
Okay, that's great. Steve.
Yeah, I'll stop the share now. Yeah. So, are there any questions?
So, can you just highlight the difference between spectroscopic and photometric measurements?
So, what I saw that spectroscopic uses IR and photometric uses ultraviolet.
Is there anything else?
The photometric variability, you can use any basically you can use any color band. I mean, you can go to ultraviolet, you can go to optical, you can go to the infrared, not so efficient, but you can detect that. The difference is if you look at these classical T-Tauri stars, since they do have disk accretion, and I think it was Phillips or maybe Sean, one of you two, describe disk accretion as a mean to create a hot spot on the stellar surface as a result of accretion. And as the star rotates, you might be able to see this hot spot glowing on your line of sight. So as a result, since the spot is hot, it's going to be producing more radiation in the ultraviolet. In Astro 10 101, right, the basics of astronomy is that in astronomy, whatever is hot is blue, whatever is cold is red. So since these hot spots are hot, then if they vary because there is more or less accretion onto them from the disk, then the flux and the luminosity they produce will be changing as we observe them. And so that is more efficient in the ultraviolet. Now, if you look at weak T-Tauri stars, and these weak T-Tauri stars, they do not have disk accretion. The disk accretion is over. So the photometric variability for these stars will be primarily produced by dark spots, like the sun's a scaled version of the sunspots. So these weak T-Tauri stars will have several spots, some of them big enough to modulate the light curve as the star rotates. And then you can use this modulation to infer the rotational rate of these stars. So, and in the case of a star like a weak T-Tauri stars having dark spots, most of the variability will come in the visual range rather than in the ultraviolet.
So, if we were to look at a spectroscopic graph, so what exactly are the spikes that you would normally see, or like the sun drops that you'd see in a curve? What exactly does that tell you?
You are asking that figure he showed, Gaurav?
Yeah.
Can you show it again?
Okay, sure.
So, like those spikes that you see on the spectroscopic graph, right? So, what does that exactly symbolize?
Which by the way, which numbers are in the x-axis? What are they? What are those?
I honestly can't really see. They're really blurry for me too.
Is that a wavelength? Is that what is being written there? Wavelength? I mean, right? I can't. I mean, you are not seeing my cursor, but there is something written. So you have
I see
one,
this
two,
right here.
3, 4, 5. Yeah, right there, right.
Right here.
Yeah. So is this wavelength? Is this written wavelength?
I would assume. Honestly,
frequency?
I can't really see that either because of this tint or whatever they have over it.
Yeah.
Since it's changing color, yeah, I would say wavelength.
Yeah, it could be. It could be either frequency or wavelength, but I can't read the numbers. In a classical T-Tauri stars, you do see this spike emission, and I don't know what they are. I mean, it's in a funny. I mean, it's not even. I mean, hydrogen would have a spike right here in the pinky part of the spectra, which is an H alpha, but I can't see in there. Yeah, I don't know. To answer Sean's question, we have to know what is in the x-axis. What the heck is that? I don't know what it is.
I think it may be wavelength or frequency. Because,
frequency.
I mean, if we're talking about changing colors in the rainbow, they're usually associated with changing wavelengths, right?
Right. So, and then the next question would be to detect which numbers are those. Here in the yellow, there is a sodium line. They're important in classical T-Tauri stars, but so the hydrogen. So I don't see H alpha in there, and that's funny. Here in the blue, those two lines could be calcium lines, but again, I can't read the numbers. But for instance, when we do a spectroscopic survey of a given T-Tauri stars, what we detect is these spikes, these emission lines, they change. So you observe today, and then you have a certain display of lines, and then you observe 1 hour later or the next night, and then the spike changes. See this line that is more to the right? It has a wing to the right hand side that is kind of open up broadly all the way to several several wavelength or several frequency points from the center part. And you might be able, when I show the taping, my cursor is showing this wing here. So this wing indicates the gas the properties of the gas responsible for producing this emission. So if you observe these over consecutive nights, you can, like a detective, you can infer what are exactly the dynamics of this falling gas, or if it's an expanding gas like a wind or a stellar wind, and certainly you can rule out this the gas producing this wing as being related to the stellar photosphere. Stellar photosphere is nice, is organized, is all the same, and is more likely associated with some emission like this. But this wing here indicates something else, and then you can use several observations and spectroscopic observations, and better yet, if they are consecutive, in order to, like a detective, to infer what's going on in the external gas.
Okay, so does anyone else have any more questions?
All right. No questions. Well, I think the next step that I would like to propose is to have you guys really putting hands on data. Of course, your priority is your school and get good grades and be above, you know, uh, way above the failing grade. Have to be way up there. That's your priority. But if you have free time, I would like to propose some projects for all of you. And as a beginning, I mean, Thomas can work with me at Evergreen because you're there. I mean, you guys are part of the Evergreen High club, and you guys can get together and perhaps divide in groups of 2 or 3 and work together. And I don't know if I have members of other high school in this group as of now, but I will contact everyone through Facebook this week or later next week, and try to set us on a track to start playing with data. Um, but here's my proposal, and I know you guys, some of you have a nice familiarity with Python language, and I do have not a lot of familiarity with the Python language, but I do have with the IDL. So, and I'm trying to purchase IDL for Evergreen, and I do have an IDL language account running my computer. And a former volunteer at our observatory, he gave me a code, an IDL code that has several licenses for students, and he gave that to our students. He used to work for IDL, for the IDL company, and so I have that in my PC. So I would like to get together with you guys face to face. I could go to your high school. Thomas, I could meet you at Evergreen some convenient time and pass you the IDL code so we can start playing. And I also would give you some of the data I have on Herb AEB star, and have us start analyzing this data. Lee Rottler, and you guys met Lee Rottler when we did the radio telescope gathering, Gavert. Lee Rotter is going to be having discussions with me on Wednesday night on Herb Key stars as a way to get us kind of moving towards some real kind of a science. I know I don't have a lot of time. I can't be full-time or part-time researcher, but I can invest a couple of hours per week and talk about research and what's going on out there. We did receive a response from the includes proposal we submitted. We didn't make it, and the major no, the outline was we don't have enough data. And what do I mean by data is results like I mean, they expect us to be somehow supported by the college and the high schools, and they expect us to already have results like the number of students we have, who are they, what's their socioeconomic profile, and how many of these students are going to the university, how many of them are going to community college, and if there are high school um, teachers mentoring the clubs, how come you guys didn't mention anything about curricula that is being provided to the students? And since at that time we submitted, we haven't started yet doing research like we probably will in a month or so. I didn't have these results, this data. So it doesn't mean that the idea was good. I mean, we received some compliments for the project we want to do. We want to start with the middle school and have you guys in the high school mentoring middle school students in academics, and use your time to take classes at community college. We thought the idea is fantastic, but in order to grant funding, they want to see more data. So what I would do in the fall is to try as much as possible to collect data. And for instance, I would need from you guys to fill form, like saying who you are, what's your goals, and socioeconomic characteristics of each one, because NSF will fund programs if they are helping underserved students to achieve the goal of a PhD or to be involved in STEM oriented career, which is traditionally is not the case in the United States. So all of these efforts we are currently engaged has as a main goal is to really bring on this underserved population of students to be involved in science. And we are talking about kids who do not have family support. Probably they are in a sucking high school, which is not your case. You have a great high school, and help them to be involved in science. So so we have two things to do. One is to have fun doing science and develop research, which is pretty much the fun part. And the other part is to try to be specific on results. And because that's what society wants us to show is results. And so if we have good results, they fund us. If we don't have results, they will not fund us, or they might give you little money just to start. But if we want to start now having courses and have the courses completely entirely funded by the grant, we need to have better results.
Okay, so when you say that we need more data, do we need like to collect more data using the Gabbard telescope like we did last year?
No, this would be scientific data. No, they want a data like how many students we have.
Students.
So what is the ratio between male and female student? Out of these students, is the first time they are getting involved with science, or they had something else going on with science besides family support? What is the socioeconomic profile of all the students? How many of them are in community college? How many of them are in a high school? Out of these students in high school, what is the percentage that might go straight to the university and not use community college facilities? So I think most of you will go straight to the university. Perhaps not. I don't know. So all these details I don't know, and I couldn't write in a proposal because we didn't know. And my learning curve, as well as the learning curve of everybody else that work in the proposal, is that, well, we have to be specific. Instead of a shooting like take a machine gun and shoot everywhere, trying to get people in the middle school and the high school, fund several clubs, we have to get what we have now and then narrow down to one club, or perhaps another club, and get to know who are the students involved, who are the participant students, and get our 2 courses at Evergreen submitted. I have to submit them in the fall, and we are kind of behind on that. So besides having fun, we gotta get this data done.
Okay.
Now, the next meeting is there anything scheduled to give a talk next Monday?
Yeah. Kirtana's the last one, I think.
Okay, so Kirkasana, right?
Kirtana.
Oh, Kirtana. So would it be possible if we had that meeting at Evergreen?
Evergreen Valley High.
It could be Evergreen Valley High. It could be because I need to meet you guys and share the IDL code. So you guys should have a computer, should come with a laptop, and then we would try to share the code.
I can't do Wednesdays or Thursdays.
Which days? Thursdays?
No, I can't do Wednesdays or Thursdays.
Oh, Wednesdays and Thursdays. Okay. Then why? Can you do in the afternoon? Is it better in the afternoon after school or right after school?
I have to go somewhere at like 7, so yeah, I can do after school.
After school? How
Yeah.
about you guys? Could you guys meet after school?
I can, but I think everyone would prefer weekends. I think.
Oh, weekends?
Yeah.
Oh.
There's also the question of finding a room for us to hold the meeting. I know Mrs. Wayne, who's our advisor for club, can now host our club meetings after school on Tuesdays, but unfortunately we have a club meeting planned next Tuesday.
Oh, you have a club meeting already scheduled next Tuesday?
Yeah.
Okay. At what time?
After school, so that's 3, and I'll probably end at like 3:30.
Oh, 3 and then at 3:30. You know, one thing that I could try to do, Sean, you're not taking any class at Evergreen, are you?
Not now. Yeah.
No. I could go to the meeting on Tuesday, and then will you guys bring your computer to that meeting?
So if we want, I can talk to Mrs. Zoyne.
Yes.
I think she can stay up till like 4 or
Yeah.
maybe past that.
Yeah.
And then after our meeting ends at 3:30, we could hold Kirtana seminar
Okay.
after that meeting.
Okay. So
Yeah, I
that
can do that.
or we go back to square one. We will schedule then our online meeting on Monday because it was scheduled anyways, and then Kirtana can give her talk.
Talk.
I'm sorry.
I'm sorry.
Kirtana. No, we could have our online meeting on Monday, 7 o'clock, and then the talk that was scheduled would go normally as scheduled, and I would make your club meeting on Tuesday and share the software and the data, and that could be done in 30 minutes, I think.
Okay.
Will that work?
Yeah, so I can talk to Mrs. Zoyne about the meeting next Tuesday,
Yes.
and like I can talk to her to see how long she can stay for, and then I can talk to you later to like.
Yeah. Just send me a text, and then we can go from there.
Yeah.
Now we are a group of 8, perhaps 9. Is that correct? I mean, in a high school, in Evergreen High, you guys are probably what, 7? Am I right?
Yeah, around 8-ish.
8-ish. So let's say 3. So I would imagine 3 groups working together. Will that be possible? Would that be okay?
3 groups. Sure.
I could have you guys, each group kind of tackling one star or one aspect of a star, and I think we could have us going in that direction, to take one star and get the data of it and try to use the ideal code uh, that I have to read the data quickly and start to get information about it.
Okay.
Yeah.
So what about the sunspot project that you had us work on?
I'm assuming you guys are still going.
Yeah, we are still going. So
Yeah.
when do you expect us to like show results and all?
I'm not receiving a lot of feedback from the group. I would like to have more people. I mean, we talk a lot. Sean and I, we talk a lot. Remember that? We exchange a lot of, texts
Yeah.
for a couple of days, and that was very good. But I need that to be a little bit more um, spread out and have more of you contact me with questions.
Okay.
Otherwise, otherwise I don't get to know all of you, and I need that. When we divide in groups, I need to know, what each one of you will be working on. That's the fun of doing science, is you get to hold one idea and try to pursue that idea, finding answers to questions and formulating questions and looking for answers, and that's the fun of doing science. Yeah, so I need more involvement, and I need more questions. That's what I'm trying to say.
Okay. So I think sent this to you already, but there's like a list of all the people in our school who signed up for the research project. It has all their phone numbers
Very good.
in there. So if you feel like the need to contact any of them, you can do that.
Okay.
Yeah.
That will be very good. I will also send a message through Facebook, which I haven't done yet, with the results of our grant proposal, briefly describing what I just told you to the rest of the members who are not part of this, or who are not meeting us today, and then we will go forward. I think we have a schedule that I would like to have that schedule going regardless of being funded or not. I think we have a solid group of volunteers. Rick Francisco is there. He's a volunteer and he's pretty much working for free like a horse. And so several other professors. And so I think we had agreed to work that way for another year and see where we go. So we have a schedule of things to accomplish this fall, and I would like to go back to that schedule, and have you guys on board, and that would be great.
Okay.
All right.
So for the data that you said you wanted us to collect for the proposal, right? The proposal required that we have more data on like the students.
Yeah, for now, don't worry about it. I need to come up with a kind of a form that help to identify the students we are working with, and I will try to get a standard form in Evergreen, and then have that as a as a base, and hopefully in a week or in a couple of weeks I will have a final version of this form, and then give it to you guys, and then you fill and give it back to me, and then one of us, probably Professor Olenka, she will organize and archive all this information, because that's what NSF wanna know. I mean, who are the students involved? What they want to do? What their goals are, and primarily, what's their socioeconomical profile? Are they females or males? Because lots of opportunities are there for female students. Not that the male students don't have a chance, but there are lots of incentive for females. For some reason, in the STEM area, female students they get to college no problem, but the dropout rate is large in the STEM field. It doesn't mean they leave university, but they do something else besides science. And we want more females sticking to the science field. All right.
Just one quick question.
Yes.
How did you want us to contact you?
Is this Pranati?
Yeah.
Yeah. Email work. Email work
Okay.
beautifully. Sean likes to text me and works fine too. One day I'm gonna get in an accident because I get lots of heavy traffic, and then I'm there bored to death, and then I say, okay, well, what's going on here? And then I have Sean's questions, and then I shouldn't do that. So, but sometimes I can't avoid it. I mean, the car's not moving, right? So I'm there. So I
Yeah.
don't drive in text. I can't do that. But if the car is not moving, there is an accident, and it's very common 60-80. I mean, I do a lot in the phone driving. Rick knows that. Rick, I just talked with the Lee Rottler for 30 minutes or so today. That's what we do. I do a lot of work while I'm driving. Yes, that's why perhaps in the future I'm gonna be driving a Google car. How about that? All right. Okay. Then I think we have some plans. So Monday next week, 7 o'clock, and I'm meeting you not tomorrow, but the next Tuesday. Is that correct?
I'll confirm that with Mrs. Zoin.
Okay.
That
Sounds
can
good.
happen, and I'll let you know after.
Yeah, tomorrow I can't, anyways, because I have orientation at Evergreen exactly at that time, 4 o'clock. But next week I'll be okay.
Okay.
All right?
Yeah.
Okay. Good night to all of you.
Good night.
And email me. Email works fine.
Okay.
Okay. All right.
Good night.
Good night to you all.
Good night.
Night.
Thank you.
You're welcome. Okay, Rick, let me take the tape. Let me stop taping for now, just a second.